So we talked about this a little bit yesterday, but whenever I teach, and you've seen this before, if you took grade 10 applied, technically speaking, you should have seen this, depending on who your teacher was, if you were online or whatever. Like, obviously, I can't predict you actually did, but it's in the curriculum, and it should have been taught. As I said before, anytime I say that, don't feel bad if you don't know it, or if you just don't remember it. It might become familiar again as we go. But make a mental note. Maybe give yourself some kind of secret symbol, like a star in the top corner. And then if it's not coming to you, come in for extra help and we'll work on it. And I can give you some extra practice or something like that, right? We have a lot of practice sheets for this kind of stuff. So we can give you more. So, you know, you just have to come and talk to me about it, right? So applieds should have seen it, maybe not. Academics for sure. And this is the easy kind of the two kinds of factoring that we're doing. Well, we're doing two kinds today, but the kind that we're going to do next lesson is the harder kind. So we're doing simple trinomials and difference of squares. We're going to do simple trinomials first. And as I said previously, when you're doing factoring, it's always really important to think about how you get there in the first place, because factoring is the opposite of expanding. So how do you get there in the first place? And we haven't expanded anything like this yet. So let's talk about it. What do? You multiply these. I don't want to be in green. You multiply these, you multiply these, you multiply those, and you multiply those. Right? So x times x is x squared. X times 3, oh, it's frozen, sorry, is 3x. 4 times x is 4x. 4 times 3 is 12. What do we do next? Collect like terms, add like terms. Very good. So the two like terms are 3x and 4x. So we've got x squared plus 7x plus 12. And now there's a pattern here. The questions that we're going to look at are always going to be very, very similar. So we've got x in a number and x in a number. 4 times 3 gave us the 12 at the end. 4 plus 3 gave us the 7 in the middle. And that's going to happen every single time. Right? So eventually, if you do enough of these, you skip that step and you just go straight to the answer. Now, this is not factoring. This isn't what we're actually doing today. Okay, same thing. Here's another one that's kind of an easy. X times, oh, I'll let you write it down. X times x, x times 7, 3 times x, 3 times 7. Again, take a look. 7 and the 3 add up to 10. And we're starting to see a pattern here that when we start with these binomials that are x and a number and x and a number, and you could have binomials that are other things, but if it's the x and a number and x and a number, you're always going to get an x squared term, a constant term, and two x terms in the middle. And the two x terms will always add together, and the constant will always be the product of the two numbers in the question that we started with. And it's going to happen the same way every single time. Okay? Product means multiply, right? So the 3 times 7. So for factoring, when we're looking at this step, okay, what factoring is looking at the 10 and the 21 and just trying to figure out in our head what two numbers add to 10 and multiply to 21. And that's how you factor a simple trinomial. It gets a little bit harder when you involve negatives, but that's the straightforward part of it. Okay? Two numbers that add to 10 and multiply to 21, because that's what's going to happen every time when you start with this. And when you're factoring, the question's going to look like this, and the answer is going to look like that. It's because you're going backwards. Okay? So in this case, two numbers, anybody know two numbers that add to 10 and multiply to 21? Yeah, 7 and 3, right? That's kind of a stupid question because it's right there, but yeah, 7 and 3. 7 plus 3 is 10, 7 times 3 is 21. Anybody know two numbers that add to 7 and multiply to 12? Well, the answer's right there already, but, right? Like, now the hard thing about this is, if your mental math isn't great, and in particular your times tables, factoring can be really hard, okay? So that's a tricky part, and I can give you strategies for that. But it's hard, and it'll take a lot longer because you're going to be using your calculator, and it's really going to take time. I had a student years and years and years ago in a different grade 11 class, and I mean she had to pull out her calculator to do 8 times 1. And I'm like, oh my gosh, like how are you ever going to factor when you can't do any kind of multiplying in your head? Okay, let's do this one. What's a bit different about this one? Yeah. There's a negative. We still do it the same way, x times x times 3, negative 2 times x, negative 2 times 3. So it is a negative 2. Often in grade 9, people say, well, is it negative or is it minus? Well, no, that's the same thing, right? That means the same thing. So the only difference here is when I add these together, I got to take the sign into account. So it's not 5, right? I'm doing 3 minus 2. So plus x minus 6. What kinds of numbers, when you multiply them together, give you a negative? Yeah, they have to be opposite signs. So if I'm looking at something like this and I'm going to factor it, when I look at the negative 6, I say to myself, oh, they're going to have opposite signs because they multiply to a negative, so they have to, right? It's like detective work. You're deducing that. So then I say, okay, so in the middle is positive 1, so I'm looking at two numbers that have a difference of 1, right? That when they subtract, you get 1. And what two numbers multiply to 6? And subtract a 1, well, 3 and 2. 3 minus 2 is 1. Right? So the ones with negatives in them can be a little bit harder, and you just have to notice that. And there's a couple of different kinds that have negatives. So I think we'll probably see one of each type. This one has 2 negatives. Okay, same thing. So the last one had a negative in the third position. This one has a negative in the middle position. The other one is if they're both negative. Okay? And we'll see that, I think, on the next page. If they multiply to a positive, then they're both yeah, same sign, either both negative or both positive. In this case, they were both negative, but they could have also been both positive. So how do I know which? Well, if they add to a negative, they got to both be negative. So see the detective work that you're doing, that you're making these logical realizations. Any questions about that so far? All right. Now we factor. One of the harder things I think about factoring when you first see it is, and I haven't really thought about it a lot, but it's one of the first, or maybe the first time that you're solving a question that doesn't really have steps to it. You just kind of figure out what the answer is, right? Like when you're solving an equation, it's step, 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 and when you learn those steps, you can solve any kind of equation. But with factoring, it doesn't work that way. When you're factoring, you have to know that the answer is going to look like this. You just have to know that. That's part of the knowledge involved in factoring. There's no steps that gave us that. We just know that. There's no steps that are going to give us the numbers there and there. We just have to know that we're looking for two numbers that add 5, multiply to 4. Right? Now, you could start doing two numbers that add to 5 and just see if they multiply to 4, like 2 and 3, well, that's 6. That kind of thing. But there's a lot of numbers that add to 5. Because like 10 and negative 15 add to 5. So it's actually better to think of all the numbers that multiply to 4. And this is where your times tables comes in. So there's 2 times 2. Does that add to 5? No. What else?
4 and 1.
4 and 1. And it's funny how the ones that have a 1 in them are often the hardest ones for whatever reason. It looks weird that how can you have two numbers that multiply 4 and add to something bigger? That doesn't make any sense. And those can be the hardest ones for some reason. And then, this is how I do it. Put in the numbers. And then think about the signs. And the signs are, yep,
Positive.
both positive. And we know that because it multiplies to a positive, so they have to be the same sign, either both positive or both negative. So if it adds to a positive, obviously both positive. Okay? B. So again, we know what this part of factoring, a big part of factoring is we have to know what the answer is going to look like. And if your times tables aren't great, or if the numbers are really big, which for us they rarely will be, then you take out your calculator and you do 12 divided by 1. Well, you could probably skip that one, I hope, but 12 divided by 1. So your pairs are 12 and 1, 12 divided by 2. 12 and 6, or sorry, 2 and 6. Not 12 and 6, 2 and 6. 12 divided by 3. 3 and 4, and you start just listing out the pairs. 12 divided by 4. Well, 4 and 3, I don't have to relist them again, so I can stop there. If I did 12 divided by 5, I'm going to get a decimal, so that's not an option. Okay, we don't use decimals. But if you had a number like 72, you'd be doing a lot of dividing on your calculator, right? So we won't often see numbers like that. Which of those add to 8?
6 and 2.
6 and 2. Or 2 and 6. And again, both positive. Stop me if there's any questions. Otherwise, we're going to keep going. I'm looking around and I'm feeling like people are getting this because you kind of look like you're actually already done before I'm done. So what's different about this one? There's a negative. A negative here and a negative here tell us different things. So which one is this? Well, this is the one where they multiply to that. So they multiply to a negative. So don't write this down. You can do it this way if you want. It's not how I do it. One's positive and one's negative. Okay? I do that step at the end because that's how I like to do it. Two numbers that multiply to 30 and subtract to 7. So if you're good at times tables, you start doing it in your head. 30 minus 1? No. 15 minus 2, because 2 times 15 is 30. 15 minus 2, that's 13? No. 3 times 10 is 30. 10 minus 3, oh, 10 minus 3 is 7. So it's 10 and 3. Now, which one's the positive one and which one's the negative one? Easy? Huh? As, sorry. I don't know why I said it that way. Go ahead.
So the 10 is the positive one and 3 is the negative.
How'd you get that?
Because it's 10 minus 3, not 10 plus 3.
Good. And it's not 3 minus 10. Right. It's not 3 minus 10 because that would be negative 7. So 10 minus 3 is the one that gives us positive 7. So once again, negative. So two numbers that have opposite signs. There's always a question, does it matter which one we put where? Well, it matters where you put the sign, but it doesn't matter where you put the bracket. So if it was x minus 3 and x plus 10, that would be totally fine. Okay? So again, we can run down the list. 16 and 1, that always works. 16 minus 1 is not 6. What's next? What's yeah. 2 times 8 is 16. How many people already knew that? Were thinking that? Okay, good. Lots of people. 2 times 8, and is 8 minus 2 6? Yeah, so there we go. We have them. Now we got to flip over and look at the negative.
8 is going to be negative.
8 is negative. Why?
Because it's negative 6.
So 8 is bigger, so it's 2 minus 8 to get the negative 6, as opposed to 8 minus 2, which would be plus 6x. And that's pretty much all the types. Okay? So simple trinomial isn't too bad, because there's only so many types. Okay, I want you to try this one on your own. If you need a hint, you're looking at the 15 and deciding based on the sign if you're adding the numbers or subtracting the numbers. That's the first thing you kind of have to do. What does the sign tell us about whether you're adding or subtracting? So remember, in this case, because it's positive, they're either both positive or both negative. And we don't need to worry about which one it is yet. We don't care if it's both positive or both negative. We'll deal with that in the next step. So you're looking for two numbers that add to 50, to add to 8. Everybody's just waiting. Yeah, so 3 and 5 add to 8. If you were running through the numbers, you'd go 1 and 15. That's 16. 2 and, well, wait a minute. 15 divided by 2 is 7.5. That's not, like 2 is not even going to be an option. So we skip 2, go to 3. 3 times 5 is 15, or 15 divided by 3 gives you the 5. So you got 3 and 5, they add to 8. Put them in, and then the last step is to think about whether they're both positive or both negative, because we already figured that out. But we already know they're both negative. Ooh, what's different about this one? I don't think there's many, if any, of these in the homework, but.
There's a number in front of x.
Yeah, there's a number in front of the x squared. That means it's not a simple trinomial. That's what we're doing on Monday, complex trinomials, except there's something sneaky about this one. What is it? As? It has to do with something we did yesterday. You can common factor out the 2. Okay, now do this one. Now you can factor what's left. Do you still need the 2 there? Yes. this is our warm-up, and it's a warm-up because, you know, it's just some familiar algebra, and we need algebra throughout any math course, obviously. We're not actually going to be factoring until Unit 2, and Unit 1 is pretty long, so not until Unit 2. So it's going to be a while before we actually start factoring, but when we do that, we're actually going to go back over all of this, and we're going to do a day on mixing them all together, because it becomes a little bit more tricky when that happens as well. But we're not going to do that yet, really. Who wants to give me the answers? Go ahead, TK.
It's 2 times x negative 9 and x positive 4.
Very nice. Or x plus 4, x minus 9. Obviously, order doesn't matter. 9 times 4 is 36, and 4 minus 9, or negative 9 plus 4, is negative 5. Any questions? Everybody feeling okay about this? One different type. Before I ask for what this is, oh, you have a question?
Yeah. On the previous one, it was 2 and the 2 brackets.
Yeah.
But wouldn't it do just mean that it's 2x minus 18, and it's not?
Yeah, but if you're factoring fully, you got to have the 2 outside. You could multiply it in, but we keep it outside because the instructions said factor fully.
Yeah, I was just thinking that 2 won't apply to the second bracket, no?
No, yes. If you're re-expanding, if I was expanding this, I would expand that first and then do the 2 at the end. That's kind of a personal thing. I've just noticed that students are more successful when they do it that way. Did you have a question, or you were going to tell me what this is?
No, I just didn't tell you the
Okay. So notice how this isn't a trinomial. We were just factoring simple trinomials. Which term is it missing? The middle one, the x term. And because of the pattern, all of the ones that are like this don't work this way, but because of the pattern, this is a difference of squares. Okay? Because this is a perfect square, and this is a perfect square, and it's the difference between them. Hence the name difference of squares. Same thing, we just have to know what the answer to this looks like. You could actually do 2 numbers that multiply to 25 and add to 0. I think I've even seen some teachers teach it that way, but I think that's...
Just the easy way to do it is you just find the square root of the constant.
Yep.
And just do it plus minus in both.
So square root of 25 is 5, or if you just know your square roots, that, whoop, I almost minimized that. Or if you know your square roots, you just know it's 5. 5 times 5 is 25, again, if you're good with your numbers. And one of them's positive, and one of them's negative. And again, the reason for this is x times negative 5, 5 times x, 5 times negative 5, gives you x squared minus 5x plus 5x. And it always will, because those numbers are always going to be the same, but different signs. So you're always going to get one negative and one positive, but the same term, so they add to 0. And then that's always going to be 5 times 5, and it's always going to be negative, because one's negative and one's positive. Okay, try that one on your own. Just when we're done. How many people know what the answer is? Awesome. Who wants to give it? Yeah, you do.
It's 9.
Good. Plus 9 minus 9.